Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be looking at limits. We are going to describe the left side behavior and the right side behavior of the graph of a function around where we have discontinuities. So let's go ahead and begin by just answering the question in mathematics, what is a limit? A limit is just the height or the y value a graph is approaching. As we get very close to a specified x value. And the key word here is that it is approaching. It doesn't actually have to arrive there. It just gets close to this particular height. So keep that in mind. Now, given the function f of x, the limit L of f of x as x approaches c would be written like this. We would say the limit of f of x as x approaches some value c is L. And L would be some number value. But this is just the mathematical way of very quickly writing all of that down. So one-sided limits, that's what we are really focusing on here in our lesson. You could have a limit from either the left side or the right side. Those are the two sides that we're dealing with here. So let's begin with talking about the left side. If the value of f of x approaches a unique number L, we'll call it L1, as x approaches c from the left, then what we're going to want to focus on here is this little symbol there. This symbol is what we use to denote that it's coming from the left side. So I need to highlight that. If it's coming from the left side, then it's going to be as x approaches c, and then you'll have a little superscript where it's negative. Now contrast that with from the right side. If the value of f of x approaches a unique number, we'll call it L2, some different value. As x approaches c from the right, then we would denote that with x approaching c, and then it looks like plus, a little positive up there. That's from the right side, which are where the values are positive. So do you see here contrasting the different ways of writing the limit from the left? We'll have as x approaches some value, and then it'll have a little negative after it. But if we're talking about a right side limit, then we're going to be looking at putting a little positive up there. So let me show you what this looks like with a graph. Okay. So let's evaluate each limit using our graph. We'll begin here with this. We're taking the limit of this rational function. Now let's read what the limit actually is. We're saying find the limit of this as x approaches to, and what does this mean right here? That little negative up there means approaches to, let me write it this way. As x approaches to from the left. Why from the left? Because we said above, if you have that little negative after your value, then that is indicating from the left. So where is 2 on our number line? Well, 2 as an x value is right here. This is where 2 is. And we are supposed to be traveling on our graph from the left. We're looking at from the left. If I'm on the left side of 2, then I'm looking at this area over here leading up to that value of x. Leading up to the value of x being 2. But I'm focusing on coming, like being a little person here, walking from the left side. So I'm coming this way, coming from the left. Well, what is the height that my graph is at? What height is my graph flatlining at there? That is a height of -1. But what about this other? What about this other question here? It's saying find the limit of this function as x approaches 2. This is actually as x approaches 2, but now it's from the right. We're looking at a right side limit. So that's over here on the right. If I'm coming from the right, like I'm traveling from the right, so here we are, here I am traveling from the right. Well, what's the height if we're coming from this direction? It's different. This can happen. It is 1. So my one-sided limits are not the same. And I want us to be aware of that here as students of pre-calculus, and that's going to be a big part about the discussions that you will have as calculus students as well. So with that, now we've seen graphically, I want to show you all a little bit more algebraically. What if we want to do this just algebraically instead of graphing? You can. Looking at example 1, we're given what is called a piecewise function. What does this mean? That this function has 2 different pieces. It's got this top piece, the first piece, which is the rule negative x minus 5, but that piece only occurs if x is less than or equal to negative 3. So again, that first piece only occurs when x is less than and equal to negative 3. The other piece of this function is 2x minus 1. Now that only occurs when x is greater than negative 3. So let's highlight these. The less than, let's highlight the x when it's x less than and equal to negative 3. Let's highlight that in red. That's the less than. That's going to be on the left side of negative 3. And this other piece, when x is greater than negative 3, well, that's when it's bigger than. And so that's going to be on the positive side. Okay, so we've got 2 different pieces in our function, but they happen for different values of x. And so that plays into our limit. Well, we want to evaluate the limit of this function as x approaches negative 3 from the left. Well, that left side is right here. The left side is x less than negative 3. So what we'll do here algebraically, what we can do is just actually substitute it in. We can just say, okay, well, what is this going to be? What is negative 3 minus 5? Well, that actually, a negative or an opposite of negative 3, that's going to make it positive. So that's 3 minus 5. The limit here is 2. Now let's check and see what happens on the other side, because on the other side, the right limit, we have a different rule. So we'll evaluate using this piece, because this piece is what defines our function on the right side of negative 3. So that's 6 minus 1, which is 5. So we have that the left and right sides are different. Okay, so I'm going to go ahead and hold off on example 2. I want to jump down to example number 3. Example 2, you would do like we did example 1. But example 3 is a little bit different. This is not a piece function. This is a kind of rational function. And so what we would want to do here is really use a graphing technique like we did here. You'd want to graph that function in order to be able to really get a good picture of this. Why is graphing really helpful? Because I want you to be aware here, the value that we're curious about is on the right and left side of negative 2. And if I were to plug in a negative 2 into this, well, it would be to say negative 2, the absolute value of negative 2 plus 2, which is the absolute value of 0, which is 0, but that 0 is in the denominator and it's undefined there. Do you see how that wouldn't work to take the algebraic approach like we did above? So we really are going to kind of think about using a graphical approach here. So you would want to take and type this into your graphing calculator. And so once you do that, you're going to see a graph that's pretty straightforward, literally straight lines, kind of like this one that you saw over here. And so if you're looking at on the left side of this discontinuous function, right, because it's got a major break in it, if you're looking at the left side, what height is it at? Using your graphing calculator, what height is that one at? If you're a little person traveling from the left, from those negatives, getting close to -2, what height is that at? It should be at a height of -5, which we found, let me make this note over here in blue, to use graphing calculator. All right. Now, what about for the other side? What about if we're looking at the right-hand limit? If you were traveling on that graph, coming from the positive section, moving backwards towards -2, what height is that function at? It is at 5. All right. And the same, you would want to really take the same approach here on example 4 and 5. You would want to use your graphing calculators in order to do this so that you can see these discontinuous functions more clearly. When you have piecewise functions like we have here in 1 and 2, you can just kind of substitute into the pieces. But if you have functions like this, rational functions, you're going to want to use your graphing calculator to better analyze your graphs because they're going to look maybe something like this. And so you'll use your graphing calculator to see more clearly what's happening on the left and right side of your different values of x. Y'all, that's it for this video. If you had any questions on limits, can you take a moment and share those now? And until next time, stay fired up.